today I will be walking you through the how to create such kind of visualization. So basically it's a dendrogram chart that I created for the client presentation for the Trinity Partners project. So today I will be walking you through this. So basically, this is a dendrogram chart, or we can call it a tree map also. So this is basically used to visualize the hierarchical data or the hierarchical view of the data and make it easy to spot the pattern. So we will be using data densification technique for this, and to make these curves we will be using the sigmoid function, that is a mathematical function. So let me start with the data densification first. So what data densification is? So for data densification, we will be multiplying the number of rows that we have in our data by some number. So suppose we have in total 1000 rows in this data. So what we will do is we will create a new Excel sheet named as path. Okay, where is the path? Yes, so yep. So this is a new Excel sheet where we have created a path with 0 to 200. So now we will do a cross join for this orders table. Let me connect to the path. Now what we will do, we will have a cross join of this path. Yes. So to create a cross join, create a calculated field with 1 that will give us the cross join. Okay, so now we have multiplied our data by 2. So whatever the number of rows we have, we will be getting 2 rows for each data, like for one for 200 and one for path is equal to 0. So now what we will densify more our data. So in this technique, by just multiplying 2, we will get much more times densified our data. What we will do is now we will create the bins from this path.
So Jairam, just for my understanding, so what is the exact way you densified the data?
Okay, to densify the data, I will create the bins and then index them.
Okay.
According to that.
Okay,
yeah.
Got it. Understood. Okay.
Let me do it once. Okay.
So this is what you're doing right now. Yeah. Okay.
Yes. So I'm creating bins. Okay. So now if you can see, if I will pull it into details, yeah, I will have only 2 points. But now, if I will have that index calculation here.
Okay.
Yes. See, so now from 2 points we are getting 200 points. So this is how we have densified the data by 100 times. This is the data densification. To create the curve, we need this data densification, because at every point we need much more points to create that curve. Okay, so now let me create all the calculated fields required for this chart. Okay, first the amount of sales for each one. Window sum of sales. Okay, the same calculation for the total sales also will tell you the reason why we are using the same one. Total sales, yep, that is also created. Okay, now what we want is percentage of those two. Okay, we came back. Where is that one?
I think there's another window. You can just go back.
That is the completed. No. That is the old one.
Press escape.
Yeah. Okay, thanks. Okay, now the ratio of both of them, sales by the total sales. Okay. Now we will be calculating another ratio, that is our percentage adjusted. So in this one, we will be getting the percentage for each category divided by the maximum percentage that we have in the window. Okay. Now, okay, these are all the created fields. Now create the rank function. Okay, rank them according to the amount of sales that they have. Descending. Yeah. Now let us create the x coordinate and y coordinate for this chart. Okay, so x coordinate is the standard equation for this chart is index. Okay, so what this x coordinate will do, it will give us the x points at the size of 0.12. So we will create this from -6 to 18 on the x-axis. Now we will be creating the sigmoid function that we have. So the equation for the sigmoid is 1 divided by 1 plus exp and the minus of x. Yeah, that is the sigmoid function that we are going to use to create the y coordinate of the graph. So here is the equation for the y coordinate. Sigmoid multiplied by the rank field. So this will give each graph a particular height that we want to look it like that. So y coordinate is used for that here. Max. Okay, have it the rank. Yeah, so this is the equation for the y coordinate. Now if you can see, we have these size increased at some coordinates for each of the category, that is representing the amount of the sales associated with each category. So for that I need to create a size calculated field. So what this will do is, if the x coordinate is between 6 and x coordinate is less than or equal to 6 plus the percentage that we calculated. So for each category, if we calculated the percentage according to the maximum percentage that we have in the window. So according to that, this will decide the ending x coordinate to increase that size. We'll have x here also. Then we will have 1. Okay. Else we will have 0. And okay. So this we will be using to increase the size of that line from the particular x coordinate. Okay, now just to pull the details here. Where is the pull the subcategory to colors? Pull the x coordinate to columns. Pull the y coordinate. Okay, calculate the x coordinate using the path bin that we have created. Okay, now calculate similar for the y also. Okay, so this kind of chart we are getting converted to 2-line. Okay, now go to the edit table calculation and do the nested calculation. So for the rank that we are calculating, so we needed to compute it using subcategories. Okay, and for the y coordinate to give the desired height, we also need to calculate it among the subcategories. Yeah, so this kind of chart that we are getting for now. So now what we need to do is pull the size here. Okay, now the size calculation computed using the path. Okay, so now change it accordingly. So what we want is, okay, we want total sales to be calculated along subcategories also, so that the total sales will give us the sum along all the subcategories, and the only the normal sales will give you for the each of the category. That's why we use the same formula. And the percentage adjusted, we want that also to be calculated along subcategory. So now if we can see, this length is according to the percentage contribution of sales that we have from each of the subcategories. Let's just reverse it. Okay, now we are getting. Now let me do some formatting. Hide it. Okay, now for the text field, what we want is phones. Okay, category and the sales associated, amount associated. So category and the sales. Okay, allow labels to overlap. Change some formatting. Category to be in the bold. Okay, have it here. Yes, alignment. Yeah, now fine. And what else? Color. Okay, we will change this format. First the grid lines, we'll off all the grid lines, 0 lines, axis rulers and axis tick. Okay, now we will do some shading of black color. Now the entire view, will increase the size to somewhat this. This is looking fine. Yeah, so this is, and for the another sheet that we are having here, that is giving us the total sales number. Shooting. Okay, change it the format, currency. Yes. Rupees. Yes. So, any doubts still here in this one?
Nothing from my side.
There is a couple of questions. That total sales number, right? So since we have duplicated the rows twice, right? Is it giving us the double the amount, or did we do some calculation to adjust that doubling of the rows?
Okay, yeah. Oh, we need. Okay, I haven't divided by 2. We need to divide it by 2 because we are doubling the rows.
Okay. Okay. Got it.
Yeah. Yes. Now we are getting the correct numbers. Yeah. Anything else?
Jarish, can you open that X calculated field? I'm just curious, like,
Yes.
what was that? I didn't quite understand what they're doing there. So, okay, index -1, 0.1216. We are running the index across the path, right?
Yes, we are calculating the points according to each the index with the step size of 0.12.
Okay. So each of the one interval between 0 to 200, we are assigning points.
We are assigning points. Yep.
And that will add up to -6 to 18, something like that.
Yes, if we will put the values, we will get x coordinate from -6 to 18 according to the index.
Okay, understood. Got it. Okay, and all clear from my end.
Okay, so yeah, this is also now getting half.
So if it is -6 to 18, how does these things end up becoming even?
So, Jairaj, go ahead.
Yes. So, okay, so this curve's height.
Yeah.
Okay, so x coordinate is -6 to 18. If you can see, it's starting from here, it's ending here. So,
okay, got it. Understood.
To assign each curve the height, we will having the y coordinate. That is assigning each curve the required height.
Understood. So it is basically the sort of horizontal flow, it doesn't decide the vertical thing, right? So
yes.
What decides the height?
The y coordinate, the desired height of each of the curve.
Can you open that function? So we use
exactly my question to you.
Sigmoid and okay. So the rank is okay. So sigmoid function is completely dependent on x, and we have a rank, so which is basically based on the total sales. So basically on the amount of sales that happened in that particular subcategory, putting it on on the y-axis.
The fasteners is having the maximum rank in amount of the number. Like the phone says ranked first. Okay, and this one is suppose rank 15. So we are getting a negative here. So it will subtract the maximum amount. So for this we are getting the least height.
Right. Understood.
Yes. And for one, we will be subtracting the minimum amount. So we'll be getting the maximum height for the phones category, like that.
Right.
Okay. Just assemble the sheets in the dashboard. Here to okay. Move. Yep. So this is okay. X-axis. Yep. So this is all I had for today.
Yeah, Jairaj, can you
Yes.
explain the path thing once more? Like, I'm not really sure what you like. The index function, x and y. I understood that you're actually plotting it, right? It's something like a plot. Yeah. So, what is the densification? What is the importance of it, and what are we actually trying to do there? I didn't understand that clearly.
See, to get this curve, you need each of the points at a more densified position to get this curve kind of thing. Otherwise, it will be a straight line.
What is the densified position?
Okay, densified like
technical
okay,
term or?
Yeah, it's a technical term. We use densification in many graphs in Tableau. Okay, so let me just show you this thing. Okay, so at first we were having the only one row for each data. Okay, so by creating only two bin, okay, by just multiplying it by 2. So here, if you can see, we have only two values, 0 to 200. Okay, so in that data we will be multiplying each row by just 2. Okay, so now using this we will be getting 200 points for each of the rows. So how? Let me show you. Okay, if I will index them. Okay, first let's make sure that its missing values are there. Yes. Okay. So missing values. Like this. Now, if you will pull it into detail, see, you are having now only the 2 points. But if you assign the index to each of the point and compute that using each of the bin, like that, you will be get your data multiplied by whatever number the bins you have created. Like if we have created 200 bins, we can create 5 bins also.
No, just to add on that, Sanjay. So so we in the Excel sheet, that path we have had only 2 rows, right? 0 and 200. And data densification is the term that is used to fill out those missing values in between those two extreme values. Whatever you put, 0 and 200, you have populated all the values missing, 1 to 199, right? So that term is called as data densification. And why are we doing that here is, if you, Jairaj, if you can go back to that sheet. Yeah. So if you would notice, you have bar graphs on the extreme right, okay, on starting on a certain x-axis, certain x point, and you have the starting point there. Now it's Tableau, it's not like a PowerPoint, right? So we have bar graphs on the right, we have a starting point on the left, so I can insert a curve directly, or I can draw a curve from each of these connecting to that, right? So Tableau needs, for any line or a shape or anything that you want to create, it needs data behind it. Then only we will be able to create it. And that data densification, we are doing it just for us to arrive at those curves, the sigmoid curves, which Jairaj just mentioned, leading from that starting X point to wherever that bar graphs are starting. So because for that we are getting, so if we don't need those curves, I think we can directly show those bar graphs. That shouldn't be a big problem. So we are doing all the data densification, all that thing, for us to be able to get those curves from the starting point to each of those individual bar graphs. So this is something very common wherever we need curves, circles generated, etc. People use this data densification and that path thing that we used very frequently and extensively to get all sorts of curves and figures.
Yes.
So why not create more bins initially itself? Why did we create?
No, so if you create more bins, it will just duplicate your data to an extent that you can it will lower the performance of your data, right? So when we had only 2 rows in path 0 and 200, we are not duplicating by a large factor, right? We are only doubling it. If you have to create 200 rows, we are making we're putting so much pressure in terms of how much data we have, and it will lead to the lower performance, right? So we use the data densification, that show missing values, that sort of a concept inside the Tableau without actually duplicating the data to 200 times.
Yeah.
Any reason for why choosing 200, or is that
No, you can choose anything. It's just a random number.
Okay. Jairaj, if there is any material on this, it would be nice if you could share it afterwards. I'd like to read on it.
Yeah, I will share. I will share the whole on data identification also, and this sigmoid chart also.
Yeah.
Both.
That would be nice. Yeah. Thanks.
Okay. Anything else?
Nothing else for me.
Okay. So let me just close it here.